right, so welcome to the first Neurosity stream, where I'll be talking about all things Neurosity and Notion and the different products that we make. Today I'm going to do like a little bit live programming where I try and hack some of my productivity. So I've been working over the last couple months with Neurosity to make historic insights into my productivity and what does that look like. So sort of the first idea here is that we're trying to help programmers or developers be more efficient by helping them get focused faster and stay focused longer. And we do that with the use of a brain reading device. Notion, it doesn't weigh too much. It weighs like about as much as an iPhone, and in fact it has about everything an iPhone has in it, except for cameras and mics, all the stuff that sort of spies on you. And this device has 8 sensors on it, and the sensors are replaceable, so you can just like fix them just like that. Kind of like how you change the tires on your car, you change the tires on your electrodes, or change the electrodes because they wear out at the tips. We're working on longer lasting ones, but for now that's the best we got. And it's extendable, so if you have a bigger head, you can just sort of extend it like that. It's got little numbers in it so you can see, sort of how big it is. I always leave mine on 3. I assume other people like different numbers. And it's really based on how it feels. So it goes right on your head, sort of like this. And the whole idea here is that you can't really see it from head on, but you can see it from the side. And I'll probably be wearing mine for, the majority of this, screen capture. I'm trying to do like an hour and a half and try and do about 25 minutes on, and then if anyone has any questions or anything, I'll take a break. But yeah, so the idea here is that this device is always streaming, and it's always reading my data. And if I go over here and I share my screen, you'll see sort of what the console looks like. And this is the entry point for developers. This is localhost. So if I go over to console.neurosity.co and I log out, I go AJ +2. This is an account I made a little bit earlier ago. And I go over here and I go localhost right here and I copy my password. Sorry about that. It looks like the stream went down for a second. It should be back up by now. I don't know why my OBS has been crashing. I just started using it, so if it crashes a little bit more, I'll restart my computer again. CPU is at like 7% though. This is a good Mac. Yeah, so what we're seeing here is sort of my productivity data over time, and I have calm and focus are the 2 things that we use at Neurosity. And so you can see here the dips are a lack of productivity, and sort of this straight line is good productivity. So you want your productivity, when you're in this like straight area is when you're in the zone, you're programming, and when it's down here at the dips, then that's, when you're not productive. And so the whole idea here is that I want to be able to count the number of times I was distracted. So I sort of want to get a number. I want to run an algorithm over this data, and I want to count 1, 2, 3, 4, 5, 6, 7. Maybe this counts as 1. 8 times that I got distracted throughout a session. And that way I can sort of create a couple different metrics on this and statistics on this data, such as you lost focus 7 times this session. You had, and I define productivity by total time you spent programming minus your distraction times. So if we're actually able to measure how long I get distracted for, you can see here at 12:02, I was distracted for a little bit, whereas here it was a quick one. I want to subtract the total amount of time here from this whole duration and sort of come up with this number of like, okay, you spent 30 minutes programming, but 20 minutes of that was productive and 10 minutes of that was distracted. And I think that that's really powerful data for myself, especially as I struggle with ADD and different things like that. I definitely get distracted very easily. So I really want to be able to give myself a better understanding of like when and where I'm productive. And if you go look at my personal account for the activity log, I got it. I've been doing this for a couple weeks now, and you'll see a bunch of information filled up, just like on GitHub. We call them snapshots. Snapshots are these little dots here, and these little dots represent a probability. You can see right here, if I zoom in a little bit, it doesn't actually make that bigger, but it does. You'll see my probability at this point in time for my calm metric on a scale of 0 to 1 was 0.6. 1 being, very calm and present-minded, and this is based off the alpha brainwave, this metric. And then over here, you can see it dip down to 0, 0.23, different things like that. You can see it really obviously dip. And so yeah, so that's the gist of what we're trying to do. So I want to create a number that sort of matches up with that. And this whole thing is actually written in React. React is a really nice programming sort of library framework for JavaScript development. And it runs over here in my VS Code. So if I jump on over to VS Code, you will see the code that actually makes this whole thing work. So if I go npm start, which essentially runs the development server, you'll see the site come up over here. In 1 second. There. So you can see here, it's the same thing that you get over in the developer console in production, when you go to console.neurosity.co, but it's running locally. And that means that if I make changes, if I crash something, it'll be reflected in here. And Alex, my business partner, has done a great job of setting up this create React app so that it uses something called hot reloading. So if I make a change over here and I press save, then it automatically gets reloaded over there. And it's super, super useful. This isn't written in TypeScript. This is written in just regular JavaScript, and then Babel takes the code and transpiles it, and that's what actually is ran over here in production. Yeah. So the whole idea here is that this section is a component of in React, and I gotta admit I'm like a horrible React programmer, and I'm pretty new to it. So if I'm doing something terribly wrong, please let me know in the comment section. And but I do know enough, and I generally will try and make things work, and then Alex will help me for a little bit, and we'll get it actually looking pretty. So let me see here. So the idea here is that all of these data points that you see here, if we just look at Calm, for example, is an array of data. And I was digging around here earlier, and I wanted to sort of see, well, okay, how's this work? And so, like, how are these actually being plotted? And what we find is that we're using something called a polling query. So it's actually going to a database, and it's getting this historic data of my focus data. And if I, for example, took a break here and I said, okay, well, how's new data generated? If I hit start, you'll see a number instantaneously start coming. And this is sort of like the gist of Calm. It creates this number, and it changes as we vary in focus. And the creation of these metrics is then creates this historic data, which is then available over here, up here. So in 1 second, this will refresh, or I can refresh the page. And you'll see that there's now new data for 5:15 p.m., 5:14 p.m., just like I did up here. Or, that's the time up there. So yeah, so, we want to count these dips. And I want to create a number that's like 5 or, counts the number and prints, a little label out there. So if I wanted just to sort of show you what I'm thinking, I want to have something that says like div stats, I guess this would be like number of distractions. And we're just going to kind of get this going quick. We don't need to make it perfect. But if we said, let's see, I should probably want it down here. Const stats data is equal to, and I hope you guys can see this. I can make it a little bigger. If I say stats data is equal to number of distractions, and my spelling's atrocious. I could then come down here and say stats data dot number of distractions, and this will come in use a little bit later. And check this out. This is like my favorite part. If I come over here, let me hide that. Come over here and I hit save. It'll automatically cause this, should automatically cause that to reload. There. So there it reloads. And now you can see here this little thing that I put in. And we'll worry about, making it look pretty with everything. But if I, come over here and I update that number to a 1 or, 7, it'll come reload that. And you'll see like that's sort of what it will look like. And that's the first thing I want to create. And yesterday I sent out a tweet asking people for help, like, how would I actually go about counting the number of dips, the number of distractions during, and you sort of extract that. And if I go over to my Twitter, I click on my profile name, at Andrew J. Keller. You'll see here, how do I count the dips? The dips are distracted times. The long periods of no dips are productive times. I want to figure out how to count the number of dips, and then also how long I'm productive, where productive time is equal to the total time minus distracted time. And so we see I got a couple of people throwing out ideas there. I'm not sure what an RPE is, but if you're just calculating the number of dips and the duration of each dip doesn't matter, which is our first goal. So Scott Burwell is right on. The first temporal difference of the signal might give you a better picture of the frequency of dips. And let's see. So if you were to factor in the duration of dips versus the duration of total time, you'd first want to center x minus the median and scale the signal by some reasonable metric, and then sum x. That seems quite difficult. Cluster the points in scikit-learn, write to a list. Interesting. There's one thing I want to try just in the beginning, but model change over time, add range around that line, find values less than the lower end of that range, total time. Range would be something like 95% of the values are within x of this line. And I was like, what do you mean? And he said, no, like the equation ax squared plus bx plus c that best fits the lines on your plot, but average is a good place to start. So yes, I thought that was kind of an interesting point of like how we can start at least easily, because I don't want to go too crazy here. At first, I want to sort of get an MVP and see if this is actually useful information for me. Right. So then going on, we're going to essentially think of like, okay, how do we get this data, right? And I think one way that this works with React is that every time this page is rendered, you're going to have this function called. Something like get chart data is getting called quite frequently. And I can show you that that's actually happening, because if I go to console.log chart data and I hit save, it's going to refresh over here. And if I view developer console, you'll see over here all the data. And if I sort of start messing around with the page, it'll start getting called again. And if I click different things, it'll get called a lot when it's rendering. So this is getting called a lot. So I think that's at least something where we could start calculating the data, start trying to calculate these dips. And so if I go over to here and I want to sort of get a start on this, I could say something like const, let's see, number of distractions. I don't know if I want to do that. I guess I'd do something like, let me try this for a second. Not sure this is going to be the right way to do this, but let's give it a shot. Number of distractions is equal to, and this is going to be a new function I'm creating, stats data. Close that out. Get stats data. And we're going to send a day, metrics, maybe labels, just because I know that that's going to be useful. And so if I come down here and I create a new function called function get stats data, it's going to be very similar to this. We can probably actually end up taking the first half of this, which is how the chart is rendered. And should add another one of those so I don't get yelled at. Boom. Okay. So now we have this get stats data. And this is going to be constantly sent every time this function is re-rendered, the updated data. And this is important too, and we use this a lot because every minute we want to go fetch the updated data from the server. So every polling interval, we're going to every 60,000 milliseconds or 1 minute, we're going to go hit the server, grab the latest historic data, my historic focus or calm data, and we're going to reload that. And so it's nice because the stats data will always be updating. It'll be dynamic. It'll be a good user experience. And just as an example, I can do something like return, and this is going to be our number of distractions. And so, if I return 3 here, you'll see over here, get stats data is not defined. It is now. Let's see here. This needs to be outside of here. Hit save and recompile. And now, objects are not valid as a child. Okay. Haven't got to see that yet. Let's see something here. Interesting. Okay. Well, that was lucky that I found the error quickly. Okay. let's try this. If we return number of distractions 3, I want to get this stats here to say like 3. I want to make sure that we're able to update that. So let me try this real quick. New stats data. Let's just try that. Okay, good. So we are able to update that. Okay. And if you don't believe, and that's good. Okay. So this metrics right here is an array of objects. And let's just take a look at sort of what that looks like. If I do console.log, and I'll do metrics. I'm a big console.logger when it comes to JavaScript. And if I do option command J, you get the console. So metrics, see this array here of 1,118. Well, look at that, 1,000, 1.1. It's the same thing. And so then if we come over here and device ID, you can see that the first one is calm probability. And this is what data from Notion looks like. It comes in a lot of the time as a nice JSON object. This is the device ID it was in. The probability here is this big number. We only are really caring at this point about like some of these. The higher end for accuracy, and then timestamp, when in time did this happen? This timestamp is, in the milliseconds since the great epoch of 1970. Yeah, so cool. So now we know what's inside of here. So it's an array of objects, okay? And what do you do with an array of objects? Well, you can filter them, you can reduce them, different things like that. But what we need to do is essentially, like, let's just say right now, to keep it really simple, how about any time the number is below 0.2, we count that as a distraction. Like if that was the simplest thing, how would we actually go about doing that? You could do something like const distracted metrics is equal to metrics filter metric let's see if I can do this right. Metric, and then return, and the filter, if it's true, it returns it. If it's false, it filters it out. So you would want to do something like metric.probability is greater than, 0.3 or less than 0.3. So now you could look at log distracted okay. Now if we look at this again over here, I'm sure I already reloaded, and we look at, you can see here that metrics is an array of 1,118, but distracted metrics is an array of 257. So what does that mean? It means that we just in a couple lines of JavaScript filtered out any value that's over 0.3, and that's helpful because now we have this like array, and we can start thinking about okay, well, how's this going to work? And if we look over here, let's see. I think we want to also only look at calm as well, not focus. Okay, so it looks to me like this data starts very low at 0, and then it kind of shoots up, and then it has dips here. And ideally, these dips are counted as our distractions. So obviously 257, if I returned like this number here, distracted metrics dot length, you would see something like, I don't know, 257, I guess. And it's saying that there are 257 distractions, which is kind of a lot. You know, I kind of want like a bigger number. And so it's starting to work, but I kind of want more accuracy. You know, telling someone they were distracted 257 times is not accurate. It's just that there were 257 data points whose metric was below this 0.3. Okay, so let's see. If we want to go ahead and start doing this a little bit better, let's go over to Twitter and let's look at Kyle Matthewson's sort of idea. And that's range would be something like 95% of those values are within X of this line. Okay, so he said average is a good first place to start. So let's start there. Can we get an average of all of these numbers? You know, that's sort of the first question. The way I would go about doing that, let's see here. Actually, first let me just filter and metric.label is equal to column. I just want to see if this affects it. It does seem to affect it. Okay, so there are multiple labels in there. I bet then if I remove this though and it re-renders, and if I go over here to focus, okay. So it seems like we're gonna have to do two different things. So let me just pull this apart real quick. So we're getting both calm and focus. Yeah. So let's see. And I bet there's labels. What is this labels? All right. I just want to see what this labels is real quick. Labels is an array of 2, and it's calm and focus. I bet if I remove focus, labels is going to be still calm and focus. Interesting. You would think that that would be just focus. Okay, so that's not going to be as useful as I wanted. Maybe let's work with this focus data for a second. Focus seems to be a little bit cleaner than the other one. Focus is based on gamma, calm, the gamma brainwave, and the calm metric is based on the alpha brainwave. Let's look at the focus one. So if I just look at the metric for focus, and we calculate that, we have a total of 56 distractions. And we're just looking at focus here. So that means that there's 56 points where the line falls behind here. And if I even go, you know, and I make this smaller, it'll probably be pretty close. So we're just looking at, let's see, 10 is pretty good. So that's 1, 2, 3, 4, only when it drops below 0.1. So, I mean, that's not not horrible. It's pretty informative. We could say, okay, I was distracted 10 times, but, and the reason why that got better is I put it below 0.1. But really, if I count this, I would say that like anything where it dips below like 0.2 should probably be calculated as a distraction. Let's see. So there should really be, 1, 2, 3, 4, 5, maybe 6, 7, 8 times where we have like these distractions. So I heard that there were some different like libraries here that we could use, but the average is where we want to start. So to find the average, I think the first thing you would want to do, obviously there's many ways we could do this, but if I wanted to go to const average is equal to metrics dot reduce. I want to reduce it into, I think it's reduce. Let me go over here and look at array reduce. Let's take a look at this. Accumulator. Okay. Okay. So yeah, so if we want to come over here, and we're just going to do something real quick. We're going to say const focus metrics is equal to this, and calm metrics, I know it's ugly, but let's just do it for a second, is equal to that. We'll be able to be a little bit cleaner. I just want to look, because I just want to look at focus right now. And so if I go over to focus, I really don't need that for this second. And I go over to average focus, and I guess the number here, let's see, reduce, and it's going to be the accumulator, and it's going to be the current value, and that's equal to accumulator plus, I guess this is metric. Probability. Let me see, this actually may be a bit easier way to do this. Some array of objects in JavaScript. Let me just pick this out. I'll bring this over here. I'll be honest, I'm Googling it right now. Some values of objects in array. Array reduce. Okay, so we're pretty close. Okay, so I think that is right. But what they're not doing is dividing it. Okay, so let's keep just playing this out for a second. Function, okay. Thought you had to initialize this, maybe not. Okay. Just see what this is printing out. If you have a better way of finding the average of an array of objects, feel free to say something in the comment box. Or if you have any questions, happy to answer any in the comment box as well. Okay, so let's see here. Come over here. Distracted metrics is not defined. We're going to put this back to 0. Hit save. Oh boy. So it looks like it's a giant number. And I think that's because metric probability is that not how you do that? Yeah, that's how you do that. I think it's saying that the average probability is a number, so I wanted to convert that. There's gotta be a way to do this. Well, I'm trying to do it fancy. Could just do it ugly. Let's just do this for a second. We're going to do it the old-fashioned way, and I will optimize later. And we're going to do sum plus equals, focus, metrics. It's just the ugliest way to do this. There is a better way to do this. I will figure it out. Dot probability. I think we need to make this a number. Let's do that. And then we're going to do const average focus, average focus value is equal to sum divided by the number of focused metrics. So we'll do this, and that'll give us some average focus value. Good chance that I'm messing up how to convert a number in JavaScript, but average focus value is equal to 0. All right, let's check out what our sum is. Sum is equal to 0. Oh boy. Let's see if I know why. Well, I don't know why, but I need to have that incrementing on my counter. So my loop is incrementing this I number, so I need to go through each index of the array, get that, and now my sum is actually a valid number. So now sum divided by the number of items will actually give me the average, which is 0.41. Okay. So now that we know the average, oh, someone let me know. Let's see. Filtering distracted and focus times. Creating and updating an average for both that varies in time. It's an interesting idea. That will definitely be something we do. Someone said, Luciano said to update, have like a moving window of time that is, say, like the last 300 seconds, and you're counting the number of focused and distracted periods. I want to just get this into static data first, and then we'll work on like real-time counting distractions. Let me see here. Okay, so if I look at just focus, and we know that the number, we dynamically found out that the average value for this line here is about 41.806, which is right here, which looks about right. We can say, and this is where I'm sort of starting to get like a little bit more creative, but if we say that, like we look at the time where it dipped below, so right here, probability 0.35, right? This is one distracted period, and then it dips up, end distraction, it dips down again, distraction time starts again, and then this is all one period, it dips up, maybe it resets it. I think that would create the metric that we want, because it's here, it's above, it dips down, and then it goes back up above it, dips down. I think that's closer to the number that we want, where it's dipping below the average, and then it's coming back up above it. And maybe the average, you know, plus 0.01 would be a good way to sort of set that. So we would look at, yeah. So let's see. So the next thing I want to look at, if we have the average, we have a series of timestamps, right? We want to note when it dips down and when it comes back up. So if we have an array, let's do this again. Of this, we hit save, and we come down here, and we're looking at just the number of focus metrics. And I know this isn't pretty, and I know it's dirty, but let's just optimize later, get it working first. So we're running through this list, and we could, you know, if I looked at here and I said console.log focus, let's see, I go metric equals focus metrics sub I, and I go and I take a look at this metric, and I go metric dot timestamp, and I hit save. Over here we're gonna see a ton of timestamps, right? So each of these timestamps are a point in time. So we could, we could say something where we're running through this list, and the only thing we have that's guaranteed is that these timestamps are at least sorted and ordered, right? So we could kind of know that, like, oh, did we get above the average? Are we not above the average? Are we still above the average? Is something we could do. So if we said something like, let's see, we have the average here, and we want to do const, we're going to just lower this average down a little bit to like 0.03. So we want to do something like average focus value is equal to average focus value fixed. Fixed is going to be equal to average focus value plus, I guess, minus average focus value times 0.25. So if I think about that, that's 0.4 about minus 0.4 times 0.25. I guess we want to do like 7.5, 8. Yeah, that was right. Okay, 0.25. Okay, we'll get something like 0.3. So I think that's going to be helpful, just because we want to go a little bit below the average, not just at the average. I think that's what Kyle was sort of saying here. 95% of values are within X of this line. So let's go back over here. Hit save. Is that right? Yeah, okay, order operations. So then I go over here, see this. Oh god, we definitely don't need to print that out anymore. Okay, let's see here. This will load eventually. Although my computer does sound like it's blowing up. There it goes. Okay, so yeah, 0.31. That, I like that number. It's gonna be good. I think that's a good idea. Essentially, why I wanted to do that is because 0.4 is kind of high for some of this. I want to just go a little bit lower. I want it to be dynamically created, not automatically created, so that if that number shifts around, it's still sort of automated, and we're saying like, okay, 25% of that. And let's see here. So now if we come back over here and we go, let's see. I don't know. It's gonna be ugly. It's gonna be ugly. Doesn't matter. It's gonna be ugly. Let number of distractions equal 0. And we're gonna come down here and we're gonna remove this. Okay, I'm gonna remove that 0 there because we're just passing this number now. We're returning that. And in JavaScript, newer JavaScript, you don't have to do something like that. It's redundant now with Babel, when we're using Babel. Because we're using ES6. So let's get back here, and we can say sort of if metric dot probability is less than average this is gonna be, I think this could work. I haven't been doing a lot of JavaScript lately, so this is fun. Is focused, let's just call it that, is equal to false. So if metric dot probability is less than average focused value, we want to say they're not focused, right? And we're gonna say if is focused, we want to increment the number of distractions. Plus plus. Wait, can you do that? Whatever. We'll be pretty here. Plus equals 1. And then we're gonna say is focused equals false. Okay. And else is focused equals true. Okay. So what is this going to do, right? It's going to run through this number of, it's going to run through this array of objects, and it's going to be looking at every single time there's a new metric. It's going to look at the probability of it, and it's going to say, are you below the averaged focus value? If it is, and we are currently marked as focused, then we want to increment the number of distractions and say we're not focused. So that if the next value that hits is also below the averaged focus value fixed, the average focus value, it doesn't count that as another distraction because you're already distracted, right? That's kind of the idea here, is that like you don't want to have to go like, if you're dipped, then like you should be dipped, and then only do we count that as another distraction when you go up and back down. So what is this number going to be? If we go over here, we can see there's 32 distractions. That's kind of a lot of distractions. So let's see what happened here. So anytime this number is going below 0.3 and back up, it kind of is a lot. So perhaps we don't want to do this focus value fix. Let's see what happens if we get rid of that. Let's just let's just try this for a second. See if it was a bad idea to try and change the average. 61 distractions. Okay, it went up. I wasn't expecting that. Why would that happen? Oh, because it's higher. Okay. So let's see if we can, I don't know, work this harder. Okay. So I'm thinking that the number of distractions should decrease. Okay, so now we're at 12 distractions, which is not bad, okay? So now we have, let's see if we check out the focus data. Okay, this is cool. This is getting cool, okay? So now we have 1. I guess it's probably not going to count that. It's going to have 1. It's going to go back up. 2, 3, 4. I don't like this. 5, 6, 7, 8, 9, 10. So it's actually pretty close because we wanted 12, and I bet it's counting this one as we wanted about 6, but it's counting this as 1 too. So let's try, and I guess it would be saying anytime it dips below 0.2, 0.205, we're going to count that as a distraction. So that's pretty close. Let's see here. So if I start streaming this data again, let's say we go to focus, start. And the one thing about focus is it's very see, I guess we should check signal quality first. Signal quality looks pretty good. Okay, cool. So that's looking pretty good. And you'll see data start to like run in here. And one thing I can think is that we may want to buffer this data. Maybe for next time. You can see it just updated. Let me think here. That's pretty good. I may call it there because we're at this point, we have stats and we're getting 14 distractions. It's pretty close to where I want to be. This could be a good first start. Let's return. Let's clean this up a little bit, and then we'll see if we can get something worth shipping. So let's just say function count distractions. We're just cleaning this up. I'm going to say, I guess this should probably be down below. Okay. Okay, so let's say number of distractions for calm is equal to count distractions, calm metrics, and then we want to do the very similar thing for focus. Focus, and then we're going to return for calm, for focus. And I know I'm a terrible JavaScripter, but actually I could do a little prettier than that. It's a little too ugly. Number of distractions, we'll do calm. Do calm and focus. Look at that. That's gonna be nicer. Oh yeah. Okay. So now we have an object of objects, and if we come back up here, we can say something like stats. We could say calm. I guess like distractions from calm state, and we'll say here alright, we're just going to put this in front of it, and we'll say new stats data number of distractions dot calm. We'll copy that and we'll say dot focus. Okay. Let's go take a look at what it looks like. Perfect. So someone's mad at me. New stats data dot calm. Can I read property calm of undefined? Okay. So wonder why it's undefined. Definitely don't need that. Let's take a look here. I guess we got a little ahead of ourselves. See if that fixes it. Okay, so that did not fix it. Let's see. Returning an object. Should be working. Calm, focus. You think that would work? Let's pause this and pause this, and then I want to just print out this new stats data right over here. Let's make sure this is working. Okay. Let's take a peek at this. Interesting. So, to me, it looks like it's working. I wonder why we have this not working. Okay, it's just kind of a interesting issue. Let's see. Okay. Stay focused. Sorry, I got distracted. I wonder if I was recording, if it would have caught that. Okay. So new stats data should be returning. I can't imagine it's because it's nested, right? I don't think that's how that works. Calm. How is it like that? Definitely does not work. Object with keys, calm, and focus. But then if I do .calm, it all of a sudden magically doesn't work. Canary property calm of undefined. Interesting. I mean, there's many different ways we can do this. I mean, let me try this, I guess. I don't like it, but I could try it. I could call this number of distractions, and get number of distractions. And then we could say, I know it's ugly. I'm curious if this is what's going to make it work. Wow, interesting. Okay, well, that's a good question for Alex, I would say. Why can I not return an object of an object with React? Okay, so there. So now we're starting to get metrics on my calm and focus state. That's about an hour of work, but it's pretty cool. So now I can measure, and I'll be testing this next couple of days, and I'll be back in a couple of days to improve on this and see if we can make it a little bit better. But it's pretty interesting. So there's a lot of distractions from my calm state, and there's a good amount of distractions from my focus state. So I'm curious to see how this works over time, and I'll be testing it, and I'll come back online soon. But thank you for watching, and this was using the Neurosity Notion. I'll switch up my camera real quick, show you what I was doing. But I was wearing it the whole time, and you can see here, pretty light. Can be worn for a number of hours. That was an hour of use, and I still got 36% battery life, so pretty happy about that. Yeah, if you want more information about what Neurosity is, feel free to drop a line in the comments. Subscribe below so you know when we're actually live. Always happy to answer any questions, support professional development. I really love when I hear programmers learn new techniques. If you have any advice on some of the challenges that I was getting stuck on, please feel free to comment below, and I'll be sure to integrate those next time as well. Thank you very much for watching, and I hope you guys all stay safe and healthy out there in these crazy times. AJ.